Okay, so moving forward with your polar coordinates. So the last meeting is, I think we are done. We know how to graph your polar equations. And again, this is essential because before you're able to solve for the area within the polar region, or let's say under that particular equation, polar equation, so we need to graph the equation first, and then afterwards is that's the time that we're going to solve for the area. So for the formula, it's super simple, and I think we can derive this one from your area of a sector. I think if I'm correct, it's area of a sector. Baka na murag ice cream. So let's say this is your angle theta, this is your radius plus sector. So again, a sector is a part of a circle na siya. So if muna siya yung circle, then let's say muna siya ang sector, di ba? Murag ice cream na. So this region is your sector. So of course, since it's part of a circle, so the radius is constant all throughout the displacement of your kaning pandere, di ba? So same na siya. So bisag asa nga point is you'll be having the same distance or radius. So in geometry, so I think the formula for this one is 1/2 r theta, and I'm not sure if it's r squared theta. I think that's the formula. Okay, so if you're going to look at the formula based on the given equation for area for polar coordinates, so it's likely the same, but looking at your terms found in the equation, so let's try to write it below. So notice that it's likely the same, but the theta here is d theta. So why do we have d theta? Because again, we don't know yet the exact displacement of your equation. So it could be from 0 to pi over 2. It could be from pi over 6 going to 11 pi over 6. So that's why it's differential theta, because your theta is changing. So unlike for the polygons, so your theta is already fixed. So let's say you have a 30-degree angle, you have this much angle for this sector, let's say 36 degrees. So that's why it's a fixed parameter theta. But for our integral calculus, so since our displacement or the angular displacement is changing, so we don't know the exact value of that angle theta. So that's why it's differential theta, and we have limits of integration from alpha to beta. So in some references, so the limits of integration may be presented as theta sub 1 going to theta sub 2, and then 1/2 r squared d theta. Or if you are comfortable with kanang mga other variables as well, so it could be also, but again, just be mindful that you need to follow the exact values for your lower limit and upper limits. So the designation won't matter as long as when you plug in the values for your equation, so it is the correct values. Okay, so alpha is, so when we solve for your areas under a single curve, so alpha going to beta, that's usually counterclockwise direction. So that's why our lower limit is alpha, and then the upper limit is beta angle. So I think it's a pretty simple equation. So I think all you have to do is remember the area for the sector, and you just have to customize it a little bit so that it's the same as the formula given for polar coordinates. Alright, so let's try to solve some problems, and I'm going to teach you also how you're going to get 1.0 for the problems that will come out in the final exam. Okay, so let's say we're going to determine the area of the inner loop of r equals 2 plus 4 cosine theta. So since we don't know yet what the area of the inner loop looks like, so what we have to do first is we're going to graph your equation first. R equals 2 plus 4 cosine theta. So again, since at this point we're now allowed to use our calculator, so again, dili gyapon siya magically appeared ang inyong mga solutions, but of course you need to provide evidence as well. So for example, you're going to use your calculator, so you have to use yung i-declare dia mode, then table. Okay, then magawa sa yung screen is f of x equals the equation. So you're going to write 2 plus 4 cosine. Again, since we are in terms of x, so theta becomes x, alpha x. Then upon pressing equal sign, so ito asked for a starting value. So you're going to put 0, then equal sign. Then end value is you're going to have 2 pi equal sign. And then the step, so let's say you're going to have pi over 6 or 30 degrees, then equal sign. So what will appear is, again, upon entering the different values, so you're going to have a table on the left that will be, so let me kuhan sa ako dito. So before you use the table mode also, so don't forget that your setup should be in radian mode. Diba, dili siya mo differ of values. So on the left side, that will be the x parameter, and the right side is f of x. So you're going to write the different values. So starting from 0, pi over 6, pi over 3, pi over 2. So kutob na siya sa 360 degrees. So 7 pi over 6, 4 pi over 3, 3 pi over 2, 3 pi over 3, then 11 pi over 6, then lastly is 2 pi. So for the value, so again, you have to write this one because again, your graph should not magically appear in your solution. So 6, and then 5.4641, 4, 2, 0, then negative 1.464, then negative 2, negative 1.464, 0, 2, 4, 5.4641, and then lastly is 6. So once you have these values, so this is the time that you're going to create your graph. So let's say 6 here is not the pita. So ito lang butang dire because the graph is only up until 4 units. The next is 5.46. So let's say 5.46 is in this region. And then 4, 2, 0. Then negative 1.464 for 5 pi over 6. So again, 5 pi over 6 is this location. So 1.46, or let's say 1.5, is, let's say, nadiri positive 1.45. So the opposite of which is negative, so it will be on the other side. So 1.5, so let's say on this point here. So negative 2, so this one is pi, this one is positive 2, so the opposite of this one is on the other side, so that is your negative 2 here. So 7 pi over 6 is still the same as 5 pi over 6. So starting with positive 1.5 on the 7 pi over 6 line, then going to the opposite side because it's negative, then going back to 0, and then 5 pi over 3 pi over 2 is 2, and then 4, and then 5, and then 6. So when you try to draw the diagram, so you're going to, so ako lang siyang ikuha na Marginani siya pag-draw. Okay? So you always start with 0 and then you follow along the angles from 0 going to 2 pi. Then that's how you get your graph. So the area of the inner loop, so this is the area that the problem is talking about. It's the inner loop. Okay? So if we're going to solve the problem here, so our area is equal to, so again, this is the solution first. So you're going to provide solutions for your graph. So again, if ni magically appeared ang iyong graph, so I cannot tell for myself if where did your values came from, di ba? So dapat may evidence. Okay, so again, the formula is from alpha to beta, and then 1/2 r squared d theta. So how are you going to get the limits from alpha to beta? So again, since we're only interested with the area of the inner loop, so inner loop ra ang ipangayo, so we'll have to look for the values in the table. So we refer back to the table again, and we're going to look for the angle where the loop starts, the inner loop starts. So kanisha is 0, then this one is pi over 6, this one is pi over 3, this point here is pi over 2. So the loop, the point 0 started at 5 pi over 6, and then the next points are 2/3 pi din nagsugod ang 0. So 0 is 2/3 pi, and then 2/3. Then this one is 5 pi over 6. This one is pi value. This one is 7 pi over 6. And then going back to 0 again, which is 4 pi over 3. So again, we're going to look for the boundaries wherein the inner loop started and ended. So it started with 0 and ended with 0. So it started with 0. So this is the angle here and the value. And then the inner loop ended at 0 again, this point. So we can say that 2/3 pi is lesser than 4/3 pi. So of course, this one is your alpha. And also it makes sense because you are rotating counterclockwise, diba? Or you are increasingly you are increasing the increment of your angles. So 2/3 pi is alpha, and then your beta is 4/3 pi. So again, you're going to look for the boundaries where your inner loop started and your inner loop ended. So starting from 0, that's the start of the inner loop. Then it niagi pa siya og 5 pi over 6 pi 7 pi, and then it closes back again on 0 at 4 pi over 3. So from start to end gapon na siya, di ba? Angular displacement. So again, since it is only governed by one equation, so since we are only solving for one curve, so it's super easy. So diretso na siya. So 2/3 pi and then 4/3 pi and then 1/2. We're going to place here 2 plus 4 cosine theta squared d theta. So if you're going to plug it in the calculator, so you can help your calculator a bit by getting 1/2 outside the equation. And then you're going to have 4 pi over 3, 2 pi over 3. And again, since the default variable for the calculator is x, so you're going to put parentheses. So since we cannot put brackets, we're going to put 2 plus 4 and then cosine alpha x and then parentheses again squared dx. So that's how you plug in your values in the calculator. So again, since at this point we are now allowed to use our calculator, so all you have to do is to provide the equation first, the right equation, before getting to the answer. Because at this point, what matters now is how you establish your equations. So if you cannot establish your equations, so that would be a problem getting to the final answer. So muna siya inyong buhaton karon. So again, if you're going to plug it in the calculator, so don't forget that you're dealing with radian mode. I mean with pi angles, so your mode should be in radians. So let me plug in the values first. So if you forgot to square your value, so the value will be negative. Negative na siya if makalimot mo sa squared. So the answer is 2.17. So you can put square units. All right, so do you have questions for this item? Okay, so murag clear kayo, di ba, ang pag-discuss? So murag yung button, so provide every details of the solution. So dili puding na kung ana basin magdumot mo nga you're going to show everything sa hasta pinaka basic na kuan. So the necessary solutions lang sad. All right, so may siyang graph coming from Desmo, so it's a bit smoother lang compared sa ato ang gi-generate kanina. So again, you're going to you're going to provide your own graph in the exam. So dili siya kanang dili mo mag-generate a graph digitally, but you're going to create your own graph. So for your problem sets later is, of course, you have to generate your own graph, but you can um, get reference from Desmos if you want to validate that your graph is correct. So ana lang siguro, di ba? So dili gamito ng Desmos for your graph, but you're going to use the online graphing calculators or other integral calculators for validation. Dili siya for your solution. Okay, so that's the difference. So for validation, for reference, not for copy pasting. Okay, so this is the solution. So 2.17. So in the problem, so iyang integrate manually, but again, can stop at this point once you establish your equation. So you can use your calculator and then get the final answer. Excuse. Okay, so since that one is a simple topic, so let's proceed to two curves now. So bali, it's the same concept. So let's say you're going to have two circles. So pasensya na bagay-bati atong circle. So let's say mo ni siya ang concept sa inyong topic. So one curve is coming from the inner circle, one curve is coming from the outer circle. So let's say you're interested with this area here. You want to solve this area. So marag pina solid geometry ba? Marag pina solid mensuration. So ang yung bahaton is you're going to solve first for the bigger ice cream or the bigger sector. And then you subtract the smaller ice cream or the smaller sector. And what you will have is kato na lang ice cream, di ba? Kaning ice cream sa babaw kay gikuha naman ang cone. Maragana siya ang concept, di ba? So since you're going to subtract the bigger sector from the smaller sector, so what will happen is if you try to derive the formula, so bigger sector is, let's say, 1/2 r squared theta, then minus 1/2 r inner squared theta, diba? That will be the area of our kaning ice cream, diba kani? So if you try to group together or factor out some terms, so since theta is common to both sectors and also 1/2, so we can factor out theta as well. And then what is left inside is the radius, or let's say the equation governing that particular radius, r outer squared minus r inner squared. And again, since our theta is changing throughout the problems, it's not constant always, or it's not fixed value. So that's why we get the integral of 1/2 r outer squared minus r inner squared d theta from alpha to beta. So again, if you're going to compare your r through solid geometry, so r is the radius. But since we are dealing with polar coordinates, r is the equation being governed by that particular outer line, and the r sub I or the r inner is the r equation or the polar equation governing the inner line. So it's not the radius. Basin you mistake it for the radius. Okay, so for single curve, so if you try to compare single curve between two curves, so for single curve, this is the equation. So 1/2 r squared d theta. So diretso ra siya, diba? Kaya you only have one equation. But for two curves, since you're dealing with two equations, so mag-minus mo kaduha. Mag-minus mo ka isa, diba? R outer squared minus R inner squared. So the concept again is the same for both. It's just the area of the sector. Okay, so let's try to solve again. So if you're going to look at your equations, so we graph first before we determine the area. So let's graph r equals 2 first. So meaning the radial distance is 2, automatically all throughout the angles. So puro siya 2. So 2, then 2, and then 2. Alright, so muna siya 2. Okay, so you can write here r equals 2. Then circle, diba? Okay, you generated a circle for this equation. So next is r equals 3 plus 2 sine theta. So again, for r equals 3 plus 2 sine theta, so we're going to use mode table. So again, for some calculators, just adjust what the value of your table is. It's not 7, so different lang sad. Basin inyong isunod na 7 sad ang inyong gamiton. Okay, so start and then step. So starting value is 0 equal sign, 2 pi equal sign, then pi over 6 equal sign. Okay, so we're going to write again the table. So x against f of x. So 0, then pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, then pi, then 7 pi over 6, 4 pi over 3, so you have 3 and then 4, and then 4.732, and then 5, 4.732, 4, 3 to 1.2679, then 1, 1.2679, 2, and then lastly is 3. Okay, so let's try to use another color for the second graph. So starting with 3, then next is 4, then 4.7. So let's say 5 is somewhere here. Then 2 pi over 3 is 4.7. Then 3, 4 pa tayo, 4, then 3. So let me erase the wrong point. 4, 3, and then 2. Then 1.2, or let's say 1.3, and then 1, 1.3 again, and then 2, and then lastly is 3. So again, starting from 0 first, and then you connect going back to 2 pi. Okay, so that's the graph for the second line. All right. So next is we determine the area that lies inside r plus 3, r equals 3 plus 2 sine theta, and then outside the circle r equals 2. So again, inside the blue area, inside 3 plus 2 sine theta, but outside r equals 2. So outside this red graph, but inside the blue graph. So meaning the area that is talking about is this region here. Ano siya nga area. Okay? So that's the points that you're going to determine. So muna siya ang graph coming from Desmos. Again, if you try to shade the area, this is the area that you need to determine. Okay, so if we're going to, again, write the formula, that will be from alpha to beta, then 1/2 r outer squared minus r inner squared d theta. So if we're going to look at the figure, so the outer equation is this line here, or this red graph here. Or earlier, ang atong gamit to is blue graph. Then the inner line here is the blue graph. So there's no problem in creating the equation because it's very obvious in the graph. So this becomes 1/2. So naamoy 3 plus 2 sine theta squared, and then minus 2 squared d theta. So our problem here is the limits of integration. So if you're going to look at the figure, so where did that particular region started and ended? So if you look, so if you're going to look at the two graphs, so it intercepted at this point, or the points of intersection are at these locations. Ano, di ba? So meaning it started here, diba? So the area started here, going towards this point here, diba? Counterclockwise. So meaning it's at 7 pi over 6 and 11 pi over 6. So if we're going to go back to the graph, so 11 pi over 6 is at 2. And then 7 pi over 6 is at 2 also. So it verifies that it is the point of intersection because your equation for your circle is 2. Diba? So mubangga siya at 2 yapon. Okay? So there's another way for you to solve the points of intersection. So if you want to use this particular method, so you may do so. Ang button ninyo is you just have to equate the two equations. You're going to have r equals 3 plus 2 sine theta, and then against r equals 2. So equating the two equations, this becomes 3 plus 2 sine theta equals 2, diba? So puro na siya r, diba? R to r. And then isolating your sine function, so this becomes 2 sine theta equals 2 minus 3. Then this becomes 2 sine equals negative 1. So sine theta equals negative 1/2. So getting the theta, so again, if you're going to use radian mode, so arc sine of negative 1/2 is negative 1/6 pi. So what we solve here is negative 1/6 pi, and what we have determined in the graph is 11 pi over 6 and 7 pi over 6. So take note that your negative angles have a positive counterpart. So the positive counterpart for negative 1/6 pi is 11 pi over 6. Diba? So if you're going to rotate clockwise, so starting from 0, so the first 30 degree angle is pi over 6, but since we are rotating clockwise, that's negative angular displacement. Muna, if you're rotating clockwise, so 11 pi over 6 is the positive counterpart of negative pi over 6, diba? And then this one is negative pi over 3, and this one is negative pi over 2 if you are rotating clockwise direction. So the partner of another partner of negative 1/6 pi, aside from its positive counterpart, is another angle in the third quadrant, which is 7 pi over 6. So I think that's the lesson in, it's a topic in your trigo before, wherein you're going to magnay pair ang inyuhang angles, diba? That will give the same result. So let's say cosine 30 degrees will give the same value if you're going to use cosine 120 degrees. Ano? Kaya naman siguro siya nga na-thought. Just try to look up in the internet for this topic, pairing up angles, if you're going to use this particular method. Is ako na siyang for verification na ni siya if I get lost in the graph. Okay? So again, looking at the table before, so we cannot let 7 pi over 6 be alpha because 11 pi over 6 is the starting value for your graph, diba? So this should be alpha, then this should be the ending part. But take note that alpha should not be lesser than beta. I mean alpha should not be greater than beta. It is always less than beta. But at this point, since alpha is bigger than beta, so unsa man siya pag manipulate. So we get the negative counterpart of 11 pi over 6, which we have solved later ganina when we are trying to determine the points of intersection through equating two equations. So instead of 11 pi over 6, because again 11 pi over 6 is bigger than the beta angle, Because again, 11 pi over 6 is the starting angle here. So let's erase first. So again, the starting value for your drawing is at this location, 11 pi over 6. Then the ending value is somewhere here, diba? At 7 pi over 6. So that's why this one is the beta. This one is the beta. Then the alpha is 11 pi over 6. So again, alpha should be lesser than beta. So instead of using 11 pi over 6, so we're going to use the negative counterpart of 11 pi over 6, which is negative pi over 6. So this will be your alpha, then this will be your beta. So going back to the equation, let's try to change color again. So since we now have your alpha and your beta, so diba kani siya? Alpha, then beta. So the equation now is the area is equal to negative pi over 6, diba? So it makes sense because the alpha value is much smaller now. Then the beta is the bigger value, or the upper limit is the bigger value. So 1/2, then 3 plus 2 sine squared theta minus 2 squared d theta. So if you're going to plug it in the calculator, so again, you can help your calculator a bit by factoring out constant terms. And then let's say you can simplify other terms as well. Okay, para makatabang mo sa calculator ninyo. So 3 plus 2 sine alpha x. So again, don't forget the parenthesis squared. So 1, 2, 3. So 1, 2. Okay. And then, so that's minus there. So instead of 2 squared, so you can put 4 para makatabang mo sa calculator, di ba? Then dx. So you can also try plugging this one in your calculator while waiting for the answer. So also, I think what you're going to input in the calculator is also very crucial, labi na if you're going to miss some parentheses along the process. So mo differ ang answer if kuwang-kuwang inyong mga parentheses. Basin maguba ang ang standard operating system sa kuan ba. Kaya di ba ang gi-follow sa calculator kay PEMDAS man. So basin niya if kulang inyong mga parentheses, so basin magkuwang-kuwang sa inyong answer sa. Okay, so the answer is 24.19 square units. So square units because it's area, di ba? Okay, so questions so far for this item. Sige. So I hope that you understood the concept. So let's try the same problem, but we're going to get another area of this na pod. So the problem is stating, so wala ako i-graph because we're just dealing with the same problem. Ito lang yung next. So muna siyang answer dahil for your example number 2. So again, take note that the counterpart, there's a negative counterpart for each angle. And then for the previous solution, muna siya. So basa na siya topic wherein when you get theta, when you get the arc sine of angle of this one, so you get one angle but there's another pair of angle for that particular answer. Sa pangitalan niyo ng topic, I forgot the particular topic for that one sa trig. Okay, so let's go to this problem. So this time is we're going to determine the area outside 3 plus 2 sine theta but inside the circle. So kung pangitaan niyo if outward, so outward aning red but inner sa inyong blue, di ba? So asam na siya dapita, so this is the area. So inner sa blue, outer sa red. So this is the area that the problem is looking for. Muna siya nga area. So again, since we know that the points of intersection is at these locations at 2, and then at these angles, so we can say that again, since we are rotating counterclockwise, so we're going in this direction. So this is your alpha, this is your beta. Diba? Alpha is lesser than the beta angle, so makes sense na siya, diba? So again, given the formula, so alpha to beta, then we're going to have 1/2 r outer squared minus r inner squared d theta. So this time our outer graph is the circle, diba? And then the inner graph is the red graph, which is 3 plus 2 sine theta. So again, if you are confused which one is outer, which one is inner, so again from 0 going to the points of intersection, so you may create a temporary sector, diba? Diba? So of course the outer one is the blue one, the inner part is the red graph. So from alpha to beta, so that will be 7 pi over 6, then 11 pi over 6. So na pi naman puros noon. 11 pi over 6. And then 1/2. Then again starting with the outer r first. That's 2 squared. Then minus 3 plus 2 sine theta squared d theta. So again, plugging it in your calculator, that will be 7 pi over 6 going to 11 pi over 6, then 1/2. So 2 squared, then minus 3 plus 2 sine alpha x squared, then d theta, dx there, dx. Okay, so the area for this one, So the area is 2.2 square units. All right, so questions or clarifications? So mas dali siya if kuan, di ba? If you're not dealing with bigger values for the lower limit kay di na mo ma-confuse if you're going to get for the negative counterpart of that limit. So basta as long as you try to remember that the limits is always measured. So the lower limit, that's why it's lesser because you are rotating counterclockwise, di ba? So just try to follow the region in the counterclockwise direction, and there you will see the limits that you're going to need in the equation. Muna nagbutang-butang og arrow dia from left to right and para inyo dyan makita nga asa na siya gikan ng mga values. Okay, so questions? So no questions? Okay, so let's proceed to the last before going to the last problem. So this is the solution. So again, sige. Katong ako ara kani siya kay detail ni siya. It's coming from kuan manggod ka na ebook. Nga ako ra siyang i-copy paste ba. Okay, para makita lang ninyo ang details. But pwede ra mo dire mag-start eh. So once you have this equation, then you can plug it directly sa calculator, then going straight sa answer then. So as long as you establish lang the equation, so masanalan ni siyang equation, so okay ra mo go directly sa answer. So mo din siya akong giingon ganina nga if you are confused on how you're going to determine your lower limit and upper limit, so you may write a sector, murag sector nga drawing, di ba? Kung tanawon niyo, murag siya sector. And again, it's always measured counterclockwise. So you start from this point of intersection, then rotate counterclockwise. So muna siya. All right, so proceeding to the last problem. Is that we're going to determine the area that is both inside of the red graph and the blue graph. So inside sa R, plus 3 plus 3 plus 2 sine theta, and also inside the blue graph. So if you're going to look at the inside of the red graph, so this one is part of the red graph also, so inside, diba? So meaning ano, yung kaning outer portion sa blue graph is not included anymore. So the problem is looking for this area. So you can make small sketches to determine what area the problem is talking about. So muna siyang so if you're going to look at your points of intersection, so you start here, then going towards again the same points of intersection gyapon siya. Okay, so if we're going to look at the problem, so I think it's difficult now to get the outer and the inner, because if you're going to measure first, so let's say I'm going to measure here. Let's say I'm going to measure a single sector first. So let me erase lang sa angkona kaning green portion dire. So if I'm going to solve it using one sector first, so let's say starting from the origin, diba? So if I'm going to create a small sector here, so it is only touching the red graph. It's not touching two graphs. Then if I'm going to go at this particular sector, so it's touching only one graph gyapon. It's not touching two graph, diba? Because our equation is, so if you try to go back to the other problems, so kani siya, if I'm going to create a small sector, so notice that it is touching two equations, diba? The red and the blue one. Diba? So same goes for example number 2. So katong area sa inside the blue and outside the red. So if I'm going to create a sector here, diba? So it's touching the blue one and then the red one as well. So I can use the formula. But for our case now, so since we are solving for this particular area, and if I try to create a small sector sa region, so it's only touching one graph. Ba? So the blue one, yeah, if dire kay ang red sa dang matouch niya sa, ba? So we cannot utilize the formula of this one. Di kita kagamit ani. So we cannot use this formula. So how we're going to go about this problem? So of course we're going to think outside the box. So in order for us to solve this problem, again, let me draw again the area that needs to be determined. So muna siyang area dire. So again, if we want to try to figure out that area, so there's a simple way wherein we can utilize the two equations, diba? So of course, one technique here is we're going to, so to get the net area, we're going to solve the area of 3 plus 2 sine theta first. And then we subtract it with the area coming from example number 2. Diba? So sa may pasabot na ko ana is we're going to solve first for the entire area of the red graph. So akong iko na. The entire area of the red graph. Then we subtract it from the area that we have solved from example number 2. So if we try to subtract that one, so this will be the area coming from example number 2, diba? So what is left is the area inside the region provided in blue. So in drawing, so we're going to solve for the area of that murag saan na siya, murag pan man siguro na siya ana. So magaya nga figure, then we subtract it with katong area sa example number 2, which is murag na nga area, di ba? So what is left is kaning area sa tunga, di ba? Mura mong nagkanangkuan ba? Mura mong puzzle ba, di ba? So if we're going to go about with this solution, so you're going to use the single curve equation, 1/2 r squared d theta. Then you're going to, so if we don't have yet the solution for this particular area, so you're going to use the two curves equation. So luckily for us is we have already the value coming from example number 2. So muna siya pag-solve sa area. Okay. So another method is, so we're going to use a blue line siguro karon. So di na ako i-solve but I'm just going to give you an idea on how you're going to solve this one. So area coming from r equals 2 minus the area coming from example number 3. So unsa man na siya nga mga areas is, we try to draw it again. So area 2 is the circle, diba? The circle. Then minus katong example number 3, katong murag lubot sa kuan, lubot sa circle ana, murag ana ra to ang katong nakuha, diba? So muna siya ang makuha yung area. Diba? So murag ana ra pud siya nga idea sad. And again is you have the same formula, is you're going to use the single curve formula. And then the next one, let's say you don't know the value for the area coming from example number 3, so 1 to 2 man alpha to beta ni siya, alpha to so 1/2, then alpha to beta 1/2 r outer squared minus r inner squared d theta. So that's how you solve that area. So again, for you to verify that you can use the formula is you're going to create sectors. So dapat it should be touching two r equations. So if not, so you cannot use the formula. So again, as what I patong i-try to erase it tanan. So again, before you can use the formula, always verify that when you try to draw a sector, dapat it is touching two equations. So for example number 4, di ba? Ang area is kani siya. So if I try to create a sector here, it's only touching one equation. And it's touching the blue one. If I try to draw a sector here, it's touching the red part only. Yan, red na sad siya, di ba? Di na po siya blue. Dili siya consistent. Wherein for the other problem, so let's say when we try to evaluate example number 2, so if I try to draw a sector here on the left part, that will be red minus blue, di ba? If I try to draw the sector on this part here, so still it's red minus blue. Murag katong topic na to before, katong upper minus lower. So it should be touching the same graph, di ba? So red minus blue still. Yeah, if we're going to evaluate the third example, so if I try to draw an equation here, so it's blue minus red. So if I try to draw it on the other regions as well, it's still blue minus red, diba? So at the center, it's still blue minus red. So it should be consistent all throughout your kuan sad. Diba murag same atong kuan, atong area for rectangular coordinates. So the strip should always be touching the same equation. But for this part is, since we are now with the sector concept, so the sector must be touching the same equations and the outer and inner equations must be the same. So muna siya inyong i-try to remember. Alright, so this is the solution. So area of circle minus area from example number 3. And then for the other solution is you're going to get the area of the limacon. That's the r equals 3 plus 2 sine theta. Then minus the area from example number 2. That's how you get the area of inside both the equations. All right, so do you have questions or clarifications? Okay. Um, okay, so wala na. So if you don't have any more concerns or questions, so the problem set, the problem set is up, and the deadline for this one is 1 week. So nakaanta mo 1 week for each problem set. So din na siya tag 10 problem. So I think in this problem set, it's only 6 items. Ah, 6 man siguro. O kani siya 6. So muna siyang mga answers kay kuan lang yung answer daan kay para maka-verify mo if sakto inyong kuan. But ako na siyang gi-post sa kuan sa Canvas as well, but wala answer lang. Ang equations lang that you need to find out. All right, so if you don't have any more questions, so I think that's it for today.